In this module, we overview types of spectroscopy that are not primarily based on the interaction of electromagnetic radiation with matter. While our discussions on spectroscopy primarily revolve around the interaction of matter with electromagnetic radiation, there are other types of experimental techniques that are named spectroscopy but do not primarily rely on electromagnetic radiation. We will provide a few examples next. Mass spectroscopy or mass spectrometry measures the mass-to-charge ratio of gas phase ions to identify the amount and type of chemicals present in a sample. After ionizing a sample, these ions are separated based on their mass-to-charge ratio, providing us with a unique fingerprint of the sample. It is a widely used analytical technique in organic chemistry, biochemistry, and even forensic science. Neutron spectroscopy measures and analyzes the kinetic energy of neutrons that were scattered off the sample subjected to a beam of neutrons. It characterizes structure, isotopic compositions, and magnetic properties of the sample. Electron spectroscopy is a broad group of powerful analytical techniques. Generally speaking, in these methods, a sample under study is subjected to excitation by a specific excitation source. This excitation leads to ejection of electrons from the sample. Then, the distribution of kinetic energy of ejected electrons is measured and analyzed. Importantly, electron spectroscopy typically requires a vacuum environment. We can classify electron spectroscopy methods in two primary ways. First, based on the type of sample excitation. The sample can be excited by bombarding it with an electron beam. This is the case for such methods as Auger electron spectroscopy and high-resolution electron energy loss spectroscopy. The sample can be also excited by some type of electromagnetic radiation. This type of excitation is employed, for example, in X-ray photoelectron spectroscopy (XPS). This method uses X-ray for the sample excitation. Ultraviolet photoelectron spectroscopy (UPS), as the name suggests, utilizes ultraviolet photons for excitation. Second, we can classify electron spectroscopy methods based on the type of energy differences probed. For example, Auger electron spectroscopy and X-ray photoelectron spectroscopy primarily involve core electrons, providing valuable data for elemental analysis. Ultraviolet photoelectron spectroscopy probes electrons from the valence band levels. It is particularly useful for identifying molecules by recognizing the characteristic electron energies linked to molecular bonds. High-resolution electron energy loss spectroscopy identifies energy differences related to molecular vibrations. A related technique worth mentioning is energy dispersive X-ray (EDX). This method is used in combination with electron microscopy and analyzes the X-rays emitted by a sample after being bombarded with high-energy electrons. It provides elemental information about the sample.